CGP, Foundation, Practice Set 1, Paper 1. It's a non-calculator paper. Between 400 and 500 there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means each of these are 10, 410, 420, 430, 40, 50, 60, 470. Again, there are 10 in between here and here, so this is 7.1, 7.2, 7.3 is here. This will be 2.5. What's halfway between 2.5 is 2.25. We're looking for percentage. 1/5 multiplied by 20. $20 donuts is one circle, 20, 40, 60, so this is 60 donuts. We needed to write 80. Over 3 days the total was 170, so the total for Saturday and Sunday, we take that away from 170. So the amount that we've got left is 30, so we need to draw this out with 30, which is a whole one, and then half of one. 20 plus 10, so you want half of one. Pineapple, oranges, add those together, and then take that away. 200 subtract 14 equals 186. So we're looking at this here, £2, subtract 14 gives you 186. 186 subtract 150. £12 per banana. 3 bananas, 12 pence is 36 pence. One minute to a quarter of a minute. So what we're doing here is we're dividing by 4. So from here we're dividing by 4, which gets us to 15. And then we take the 120, we add 15, which gives us 135. You can think of this a quarter of a minute in the same way that you think of a quarter of an hour. Because there are 60 minutes in an hour and there are 60 seconds in a minute, we can think of a quarter of 60 as 15. In this case it's seconds rather than minutes though. So we're looking at the gap. What do we do to get from here to here? Well, we subtract 7. From here to here, it is the same every hour. Now, to get from 4 and subtract 7, draw myself a number line. So, starting at 4 and counting 7. 1, 2, 3, 4, 5, 6, 7 takes us to -3. Always draw a number line if you're not sure, or if you want to check, draw that number line out and do those steps, count them, 7. You can do it for this as well. If you drew yourself a bigger number line, you can do it for this as well. When you're not going through the 0 point, like here, it is a little easier to see. 10, you're subtracting 7, which takes us down to -17. 2 marks. We start with 6. What do we have to do? We have to subtract 4. Write an algebraic expression. So this time we're putting in x here and we're doing these 2 steps. So this is our first step there and this is our second step here. We still need to do that. So we start with x and we subtract 4. So that's the step. Okay, just the same as we did it. X subtract 4, and I'm going to put that in brackets. And then we're multiplying by 11. Multiply that by 11. You can also write that as 11x subtract 4, or if you wanted to you could then expand the brackets. But it's not necessary, and you could have either of these. I'm going to write it like this. Either of those ways would give you full marks. Right, 2 different sorts of symmetry. There are 0 lines and then to rotate it, how many times can you rotate it and it still is the same shape? Well, you can rotate it once and then you can rotate it back to its original space, so there are 2. So lines of symmetry is when you reflect it. If you put a mirror, you can see the same thing each side, as this isn't. And then rotation is when you turn it round, and can you see the same shape? Well, yes, with a parallelogram you can see it. First time as it is, second time once you've turned it. There are invisible multiplications between each of these terms here, elements of the term. We then substitute in. Everywhere we see a p, we write 3. Now I can see that I've got 2 multiplied by 5 here. I know 2 multiplied by 5 is 10, so I'm going to make it easier. But you can do 2 multiplied by 3 is 6, multiplied by 5 is 30, multiplied by 7, whichever way you want to do it. It's not a horrible numbers. They're quite friendly numbers. Right, coffee is the grey area here. How many female students in year 7 chose coffee? Right, how many students? We've got 10 here, so each of these boxes, there are 10 boxes here, each of these boxes is 1. So this is 5, for instance. Coffee here, 7, so we're counting these squares here. 1, 2, 3, 4, 5, 6, 7. Year 7 students who chose tea. Tea is here. What have we got? So we know that's 15. Total. Total number of year 7 students, 8 plus 6 equals 14. Year 13, 5, 2. So we're looking at relationship between the 14 and the 7. Oh, sorry. Right. Whenever we do ratio, males to females, it's exactly, so Chen says this, we're looking at ratios, so we're looking at males to females. Year 7, males to females. What do we got? What are we drinking? Hot chocolate. Hot chocolate is white. So how many do we have here? If you want to, you can check that across. Takes us to the 10 here. So year 7 we have 15 males who like hot chocolate and 9 females. Year 13 we have 10, which is here, 10 and 6. Okay, and now what we want to do is to prove that these are the same. So if we take out a common factor of both, they're both even numbers, so I know that I can divide both by a common factor of 2. I can't then take those any down. Let's see what we do over here. What's the common factor of 15 and 9? Which times table are they both in? 5 to 3, 5 to 3, males to females. Five marks in total for that question. Right, we need to check the scale. We're told it's 2 meters. We're told it's 4 meters. I'm going to start with this 4 meters here. What have I got? How many big squares have I got? 1, 2, 3, 4. So I know that that whole length there is 4 meters, and that whole height here is 2 meters. So 1 square is 1 meter by 1 meter. That whole length there and that whole width there is 1 meter and 1 meter. So we need to draw this with a pencil and a ruler. We need to draw the side elevation. The side elevation is looking from this direction here. And when we look at this, what we're looking at is actually a rectangle. Rectangle that's 9 across the bottom and it's 2 up the base. Sorry, not 9, 6. 6 here and 2. 6 and 2 high. Each big square is 1 meter, so I can do 6 meters across and 2 meters up. Don't guess the height, make sure you take it off the diagram. And I'm going to, just to make sure I definitely get full marks, I'm going to write 6 meters here. 2 metres. Plan view. Now that's looking from above. And if you ever look at buildings on houses on Google Maps, for instance, you're looking at a satellite view, then you will know that what we're looking at drawing is something that looks like this. You're looking at the roof of a house with a single roof line, and this is what you see from above. So if you didn't know that, then have a look online. The length of this rectangle is 4 metres, the width here is 6 metres, and that's what I need to draw. Okay, so and across the middle here, it's halfway between. And we know it's halfway between because we're looking at an isosceles and both these lengths are the same, which means that both these lengths will also be the same. Halfway between here. Technically for this question you don't need to label it, but there are some questions that you get that look like this that you do need to put the dimensions on, so it doesn't hurt to put them on now. Only 2 points for this question though. So we're adding fractions with different denominators. So the first step is to find a common. Lowest common multiple of 5 and 7 is 35. Two multiplied by 7, 3 multiplied by 5. You do not add together the denominators. If you were adding a half plus a half, you would not get a quarter or even 2 quarters, you would get a whole. Okay, so think about it like this if you need to. If you can't remember whether you add the denominators or not, think about a simpler example to work with. When we are dividing a fraction, we can think of it as multiplying the reciprocal. What does that mean? Well, we multiply and then we switch the numerator and denominator over. Multiply the reciprocal, multiply, and this is the reciprocal of 2/3, 3/2. So what we're looking at here is inverse proportion. Inverse because we're dealing with people and the amount of time it takes them to do something. We know that we've got 2 and they take 180 minutes. That's in the question. So what does one groundsman? How long does it take one groundsman to cut the grass? Well, will it be half? No, it'll be double. So when we half this, when we divide this side by 2, we have to do the inverse, and we are multiplying by 2 here. This means the same as above, so this is minutes here, if I'll write that. And what happens if we go to 8? If we multiply by 8 here, we have to divide by 8. If you've got more people, it'll take less time. 8 grounds people, 360 divided by 8. This is my 8 times table down the side here. 36 is 4, carry 4, gets me to 5. We're starting at 12:55. If we add 5 minutes, 12:55 gets us to 1300, also known as 1 p.m. And then we're adding, so that's the first 5, and then we're adding 40 minutes, gets us to 1340, also known as 1:40 p.m. Either of those two answers would give you 4 marks. I think this is one of the most complex questions in the whole paper, because it involves 3 different elements. It involves algebra with the x, involves area, and it also, does it involve ratio? Let's see. There is one that involves ratio later. We need to know this as a fact. Do you know? If you don't, create a flashcard, memorise it, practice it over and over again. Right, we know the base is 6, so we write 6 in here. We know the height. We just write what's there. Don't worry that there is an x in there. Write it. This gives you 1 mark. Okay? Then we simplify this. Half of 6. Half multiplied by 6 is 3. And that would give you the other mark. We can also expand that bracket. Multiply those two together. So you can either have, or either of those two give you 2 marks. We actually need this, we need to expand the bracket, so whether you do it here or here, it doesn't matter for question part A or B. If the triangle, area of the triangle, so we've got area equals 15 square kilometres, and we know we can write the area as 6x subtract 3, then we can solve this expression. We add 3 to both sides. Oh, sorry, we divide by 6. Getting ahead of myself. And we just write the 3. We don't need any units because the kilometres, the units are already in the question. 4 marks altogether. Make sure that you can rearrange expressions like this. So what are we looking at? We're looking at this angle just here. This is CBD. If we look at this part here, we've got 144 degrees, and we've got 180 subtract 144 is 36, which gives us 36 degrees, because angles along a straight line sum or add up to 180. If you take 360 and you divide by the external angle, if this is your polygon, well, this is my polygon, this is internal and this is external angle. You take your 360 and you divide by the external angle, which is 36, and this equals the number of sides. So simply for 2 marks, if you knew this relationship, you can do it with internal angles. The calculation is more tricky and would take you a lot longer than 2 minutes to do. However, that if you need to do internal first, you don't know that relationship with external angles, then that's fine too. Right, so what are we looking at? Well, I can see some ratio in there, blue to red. So I'm going to draw some boxes. I'll come back to those boxes in a minute when I know what to do with them. So I have 72 meters squared. I have 1 litre is 9 meters. So let's write that down. 1 litre is 9 meters squared of wall. So therefore I need to go 9 to 72. How many litres do I need altogether? Well, I multiply that by 8. So if I multiply this, I get to 8 litres. So I need 8 litres. That 8 litres needs to be in the ratio 1 to 3. So I take this 1 plus 3, which gives me 4. I've got those 4 boxes there. And 8 needs to be divided exactly into those 4. So each of these has 2 litres in it, all the way across. So blue paint, we need 2 litres. They are in 1.5 litre tins, so 1 tin won't be enough. We actually need 2 tins. Here, how many litres do we need? 2 multiplied by 3, or 2 plus 2 plus 2, equals 6 litres. 1 tin is 1.3, 2 tins, sorry, 1.5, 2 tins is 3, 4.5, and then 4 tins will be exactly what we need, and therefore it is 4 tins. When you're painting, you need more than you cannot have less. You don't round down. You always have to round up when we're looking at painting an area. Otherwise, you'll end up with a gap. This is the tricky one with ratio. Right, area, perimeter, ratio, and algebra, just for fun. Area A. Sorry. Question 18, A. We actually just need the square and the rectangle. It talks about the perimeter of rectangle A and the perimeter of square B. Square B means that this side, this side, this side, and this side are all the same. The perimeter of it's a rectangle, so we know this is 5 and this is 10. Right, so it's shorter than the perimeter, so we know that this, the perimeter, all of these sides added together, has to be less than 30 centimetres. So we know that is less than 30 centimetres. And when we take 30 centimetres and we divide it by those 4 sides, we've got 30 divided by 40 gets us to 1, 2, 3, 4, 5, 6, 7. Gives us 2 left over. 1, 2, 3, 4, 5, 7.5. So the perimeter of square B has to be less than, sorry, the length of side length of square B is less than 7.5 centimetres. Triangle C is equilateral. This means that this length and this length and this length are the same, so this length is X and this length is X as well. The ratio of the perimeter. That's in the question. So I'm going to draw my boxes. Make sure they're big enough so you can write something inside them. And then we know that the perimeter A from here is 30 centimetres. So this length here is also 30 centimetres. What are each of those boxes? If we divide 30 centimetres equally by 5, equals 6 centimetres. So each of these are 6. And because it's a ratio, it means that all the boxes across here will also be 6. Now what do we know about the perimeter of C? Well, the perimeter of C is x plus x plus x. 1x plus 1x plus 1x. There's a 1 here. It's not 2, it's not 3. Gives us 3x. So we know that this here is 3x. And we can say that 3x equals what these added together make. So 6 plus 6 plus 6 plus 6, 12, 24. So 3x equals 24. And then you can rearrange to solve. 24 divided by 3 is 8. I really like questions like this when the answer at the bottom falls out as an integer. Complex, you do get 6 marks for this question, but it involved ratio, it involved an inequality, it involved perimeter, and it involved algebra. That's 4 topics all in the same question. Tricky question, 6 marks you get for it. Right, what do we know? We know that if we add all of these boxes together, it all equals 0. So if we add all of those together, sorry, not 0, it equals 1. So what are we looking at? Well, if we add all of those together that we know, I've deliberately aligned them this way so that I can add them together more easily, and I'm going to put those leading zeros, or the padding with those zeros. Doesn't make a difference to the number, it does make a difference to how we align them and see them when we add them together. So these all together equal 0.70, which means these together equal 0.30. Why 0.30? Because 1 subtract 0.7 equals 0.30. This is what's left. And we are told the dice is twice as likely to roll a 2 than a 1. So I'm going to use algebra in here. You don't have to use algebra, and if you can see it already, that's absolutely fine. But for every 1, we have 2 of these. The probability is 2. So this whole is like having my boxes. X plus 2x is 3x. So 3x equals this amount here, equals 0.30. We can divide both sides by 3, and therefore we've got x equals 0.10. It's not the end of the question because we need to put and substitute these back into the table. We're trying to complete the table. That's what the question says. 2 lots of x, and x is 0.10. Probability of rolling a 3 or the 4 is the probability of rolling a 3 plus the probability of rolling a 4. Probability of rolling a 3, probability of rolling a 4. Remember that leading 0, the padding 0 if you need it. I'm just going to write it out here for ease. The dice is rolled twice. What's the probability of getting 2 6s? So the probability of getting 1 6 and the probability of getting a second 6, which is 0.09. You can do it using lattice method if it helps you to know how to do. Just know that if you multiply, this is about a third, and a third of a third is not 0.9. 0.9 is almost 1. If we've got a third of something and we take a third of that, it has to be smaller than 0.3. This is how we get to this. This is how I know that the magnitude of this number is correct. cyclist decides to ride for hours. Speed, distance. Okay, so this looks like speed, distance, time. Units. Always start with the units if you've got the speed. It's the easiest one to then work the rest out if you need to change units. This time we know is in hours, so distance has to be in kilometres. We're in kilometres at the end, so we shouldn't have any unit issues. She's riding for 3. Oh, we do have an issue with 3 1/5 hours though. What is a fifth? Well, let's have a look. We've got distance. Distance equals, you cover the distance, you're left with speed multiplied by time. So what have we got? We've got speed is 20 multiplied by time, which is 3 1/5. Just trying to think the best way of turning that into a number that we can use. A fifth of a whole. If we work that into a decimal, we multiply by 20. So this is 20 multiplied by 3.2. And then we can multiply that by 10 and then as 2, so we can multiply 10 multiplied by 3.2 plus 2 multiplied by 3.2. That's not right. Okay, rethink. I'm going to cross this off. And we're going to start that again down here. So 20 multiplied by 3/5. This is like saying 3 plus a fifth. It's not 3/5 actually, it's 3 1/5. This is where I went wrong before. 3 1/5. So what we're doing here is we can use distributivity. We're going to expand this. We're going to look at it like we're saying 20 multiplied by 3 plus a fifth, which if we're expanding this out, (20 multiplied by 3 is 60). A fifth of 20, which is the same as saying 20 divided by 5 is 4. And then you add those two together, 64. I got a funny number. I checked it through and it wasn't giving me the answer I needed, so I came up with a different way of doing it. I went from here, which was correct. I realised I looked back, this was correct, and so I worked it out again. Don't be afraid to do that. Don't be afraid to try another answer. If you cross it out and you don't put anything, you will get points for anything you've crossed off if there is points to be had, but if you can come up with another solution, that is even better. So we've got a right angled triangle. These are the same, so it is an isosceles triangle. Both of these are the same here. So I'm going to draw one of these triangles out. This is 6, this is 10. Two ways of tackling this to begin with. If you know about 3, 4, 5 triangles, then this becomes a very quick answer. If you knew that the relationship between here, 6 is 3 multiplied by 2 gets to 6, 5 multiplied by 2 gets to 10, and then you actually know, I'm going to do it in pencil for now, that you have to go 4 multiplied by 2 gets you to 8. That's one of these lengths here. So the base length of the root is 16. 8 here, 8 here gives us the 16. It's a 3, 4, 5 triangle. Make sure you put 3, 4, 5 triangle so that they're aware of what you're doing. However, if you don't spot that this is a 3, 4 triangle and it says 6 and 10, so it's nothing to do with 3s and 4s, it's difficult to see, don't worry. Don't worry, we're using Pythagoras. So what are we going to do? We label it. That's what we do first. This is our hypotenuse, and we're going to call this A and this B. So for now, we're going to ignore the fact that we know that I know it's 8, and we're just going to call it B. Pythagoras Theorem. It's another of those things that you just need to learn. Hypotenuse, the longest side. H is the hypotenuse. Doesn't matter which way round you put your A's and B's, but do make sure that you know it's a 6 or a B. We said A is 6 squared, B squared, H squared is 10 squared. So it's telling us that this length here is 8, this length here is, so L equals 16, it's 2 lots of 8. 4 marks, gives you plenty of time to do the whole thing. If it's a non-calculated paper and you're being asked to do Pythagoras, look for those 3, 4, 5s. Negative 5 multiplied by C, so negative 5 multiplied by negative 3. Negative 5 multiplied by 4. Even number of negatives. Odd number of negatives. We've multiplied negative 5 by both of these. The column vector, the x and the y, gives us this. So we're looking first at what 6D is. Six multiplied by 7. I can never remember, so let's write it out. 7. One, 2, 3, 4, 5, 6. So 6D is 1242. Oh, sorry, without the fraction line in, it's 1242. It's a movement vector. And then subtract C. So negative C is the inverse of these. So it's 3, negative 4. It's basically negative 1 multiplied by this vector here. And so what we're looking at is 12 subtract 3, because it's a subtract here. We're looking at 42 subtract negative 4. Gosh, this is a negative number again. Combined, this is a problem solving exercise because it combines negative numbers with column vectors. 12 subtract 3 is, if I get my maths right, is 9. 2 subtract negative 4. If we're subtracting a negative number, it actually means that we are adding. So this is 6, 9, 6. No, done something wrong. Let's have a look again. I know what I've done. I have subtracted twice, or I've subtracted a negative. So here, my 6D is correct. So this here is correct. But what I've then done is found negative C and I've subtracted it. So I'm just going to cross off this. And I'm going to write my 6D, which is my 1242. And then I'm going to subtract negative 3, 4. So I'm looking at 12 subtract negative 3, which means I'm adding it, which gives me 15. And 42 subtract 4 is 38. Much better. Okay, so we're looking at an inequality, which means that we're looking at an answer. We're looking at C rather than X. Usually we have an X in the middle of these that has these figures here. So what we're looking at is 4.8, and 4.8 has to be a number that can round up and a number that can round down. So 4.8, what number rounds up to 4.8? Near a tenth of a metre, 75, and it can be 4.75, which is why we've got the equals sign here. And here, what number rounds down? 4.8. Well, sometimes we say 4.99999, but actually, without the equals, it goes up to, but almost reaches 4.85. So that'll give you 2 marks. Oh, this looks complicated. It's not as complicated as it looks. So let's see what we do with this to start with. It's Indices Laws. We've got a divide sign and we've got a multiply. We're going to start with the multiply. So 4 has an invisible 1. What do we do when we've got the same base and we're multiplying them together? Well, we add the indices together. So this here, 4, 7 divided by 4, 4, 9 can actually now be written as 4, 7 divided by 4, 10. What are we doing when we're dividing indices? Well, we take the top number and we subtract the bottom number. Please don't do it the other way around. It leaves us with -3, which can be written just like that. It also is the same as saying 1 divided by 4 to the power 3. You don't need to know that, just write in -3. That's absolutely fine. Find the values of the integers for A and B. So we know that this is the whole expression here. This equals 4A. So what is A? Well, A is -3. Can you see here that you've got A and you've got the same base 4 and 4. So whatever is up here as the indices is the same as A. It's like substitution. You just substitute in the -3 instead of the A. So A equals -3. It's like substitution in reverse. We also know that this equals 1 divided by B. And actually it was important to know that 4 to the power -3 was 1 divided by 4 to the power 3, because now we have an expression that has 1 divided by this indices. So actually this is 4 to the power 3, which we need to write as an integer. It says that. So 4 to the power 3 equals 4 multiplied by 4 multiplied by 4. 4 multiplied by 4 is 16. 16 multiplied by 4 is 64. You need to either remember that, 4 to the power 3 is 4 multiplied by 4 multiplied by 4. 4 multiplied by 4 is 16. 16 multiplied by 4 is 64. Or you can work it out as long multiplication. What have we got? 4 carry 2 and 6. However you want to work it out. So rather than this being 4 to the power 3, because actually on the answer line we need an integer, B is 64. Now that was 2 marks. Actually what I didn't spot at the beginning is this is called the difference. And you could have actually gone from this to this in one step if you knew how to do it. This is safer if you don't spot that it's a difference of 2 squares to start with. Factorise means add in brackets, so I need some brackets. Looking for common factors. I haven't got a common factor on the numbers, so actually we need the 4 in here. Oh, I see what it is. It is actually a difference of 2 squares question. So we're looking for 2 sets of brackets. We've got an x that we need at, what's the square root of this? Well, the square root is 2x, y, and y. 1 is positive, 1 is negative. Okay, so the top gets you thinking about the difference of 2 squares. If you notice that the reason that these 2 terms fall out means that we have a square number here and a square number, and a difference means the negative. And here we have the difference of 2 squares as well, which means that we put the square root of the first term, add the square root of the second term, square root of the first term, subtract the square root of the second term. Use your answer to calculate 4 multiplied by 230 squared. Subtract. So what are we doing? Well, we've got a 4 here. So we're saying that this x equals 230. And if we're substituting that in there, y equals 360. Okay, so we substitute those 2 in. Two multiplied by x, 2 multiplied by, so we're looking at 2x equals 2 multiplied by 230 equals 460. So we want to put 460 in here, plus y, which is 360, multiplied by 2x again, 60, subtract 360 this time. 460 plus 360 is 7. Oh, no, it's not. It's 8. 6 plus 6. 12. Divisible multiplication between. It's all right. 460 plus 360 is 820. I'm just going to check that there. 460, 360. Yep. 820, 460 subtract 360 is 100. This is where it all comes together for me, because, oh, look, I know what to do with this. I don't have to do any complicated multiplications. These numbers were looking really big, and now these numbers look really manageable. 820 multiplied by 100, 820, and what we're doing is we're moving this 2 decimal place to place values 1, 2 here, which means we write 82000, and the answer is 82000. Oh, I like those sorts of questions as well. And there we have it.